right, so I forgot to turn this on. So we have tangents equal to opposite over adjacent, cosine equals adjacent over hypotenuse, and sine equals opposite over hypotenuse. We learned this acronym to remember sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Okay, so you guys back to this right here. When I created this little diagram down here, and I did AB over BC equals 0.55, you'll notice AB divided by BC is right down here. This is B right down here. So AB over BC, and then I did DE over EC, and then I did FG over GC. Well, if C is my reference angle, you guys, each one of these is opposite over adjacent, right? Opposite over adjacent, opposite over adjacent. So all three of these right up here that you see are tangents. Do you see that? How would I go about getting maybe a cosine? Okay, I'm going to erase this. Okay, I'm going to go over to my computer. BC over AC. BC over AC. That would be correct. So what I need to do, first of all, is I need to find the distance from A to C. And I'm going to put that right over here. I also need to find the distance from D to C. And I need to find the distance from F to C. And then, you guys, to find the cosines, and I'm going to just really quickly erase this. Okay, to find the cosines, I am going to get my measure tool, calculate, and I am going to calculate BC. So here's BC, and divided by AC, right? Which is right here. And I get 0.88, and that is a cosine, right? What if I got the other cosines? What would be the next one? Okay, EC divided by DC. And the last one is, no, GC divided by FC, right? And notice that all three of those are the same ratio, even if I drag them around. Okay? Whenever I drag these two, the cosines all stay the same, the tangents all stay the same, right? Let's do sines. What would be the sines, you guys? Opposite over hypotenuse. So AB over AC. So find AB divided by AC. I'm going to put those right here. Okay, which one? DE divided by DC. And the last one, it would be FG, did you say? FG divided by FC, right? And these are all the sines, right? Now, watch. If I drag this around, if I drag point C around, I'm changing the angle C because those other 2 points stay the same. Oh, you know what? I'm going to measure the angle so you guys see that too. If I, hold on. If I choose that point right I choose that point right there. Whoops. And that point right there. No. Whoops. Doing that. I need to move this. That point, and that point. And I come to measure. I can measure my angle. So here's my angle measurement. Right now I have 24.96 degrees. I'm going to change this. I'm going to make it wider by going this way. Notice my angle is getting bigger. And as my angle gets bigger, it's up to 42.65 degrees right here. Notice that my tangents, which is this box, my cosines, which are these three right here, right? And these three right here are my sines. They all stay the same. All the sines stay the same. All the cosines stay the same. All the tangents stay the same, no matter where I drag it. Pretty cool, huh? All right, now I'm going to teach you guys how to use this in the real world. That's right. Okay, so let's draw a triangle right here. Oh, wait. Let's do this. This is used, by the way, you guys, trigonometry was a lot of mathematics, like I told you, is created. Mathematicians discover it and create it, and then they find a use for it later on. Trigonometry was the opposite. There was a need for it because when they were trying to divide up land in Egypt and everything, they had unmeasurable distances. And they had the need to create this to make it easier and faster to measure. Yes? Yeah, they found old math that's been wrong, and they've proved it differently before, yep. People made assumptions. No, I think that one's pretty much proven. It's right. Okay, let's do this. Let's say you have a building, and you want to know how tall it is. Okay, and so you take your tape measure and you string it out along the road, and let's say you go out 200 feet. And you measure up to the top of this building, and you measured an angle of 31 degrees. And you want to know how tall this building is. You don't even have to go on top of the building and drop a tape measure down. You could do it without going on top of the building by using trigonometry right here. How do you make the line at the top? How do I know that's 31 degrees? Because I have this tool. Nowadays they use transits. But back in the old days, they used a tool called a sextant, and it measured angles like a protractor. And they still use them today a little bit. But a lot of people use transits now, and they can measure this angle right here. They can put the transit down here, and they can measure up to the top of the building right there, and they can find that angle between horizontal and they aim the crosshairs just right up to the top of that building. I had a surveyor come and do that for my pre-calculus class here about a month ago, and we went out to figure out how tall our school was. And so anyway, we figured this out, and anyway, we did this math right here. So 200 feet right here. Now look at this. I have this angle right here, right? I have this angle right here. That's my reference angle. I have this side. Which side is this to that angle, you guys? It's the adjacent side to the angle, isn't it? It's the adjacent side to the angle. And then I want to know the height of the building. Which side is the height of the building from this side? Opposite. So I'm relating opposite and adjacent. Which of those three, sine, cosine, tangent, is this? It's tangent, right? Okay, so you're going to take the tangent of what? The tangent of No, the tangent of the reference angle, which is 31 degrees. This is always an angle right here. Equals what over what? What over what? H over 200. Okay? Opposite over adjacent, right? H is not opposite 200. It's opposite of 31 degrees. Okay? And so I need to solve this equation. What would I do to both sides of this equation to get H by itself? Times by 200, right? So I times both sides by 200. These cancel out, and I get H equals 200 times the tangent of 31. Everybody, get out your calculator. Everybody, first of all, do this. Everybody hit your mode button. The third line down says radians and degrees. Which one do you have to have it in? What was our angle in? It's in degrees, so make sure it's in degree mode. You'll learn in pre-calculus, you'll learn about radians, okay? Okay, so you're in degree mode. Okay? So now you're going to go back to your home screen, and you're just going to type that equation, 200. Now, you could put a time sign here, but when you hit the tangent button, it's implied multiplication. Notice you have your sine, cosine, and tangent button right here. Hit your tangent button. It's right here, these three, right above 7, 8, 9, 2 above 7, 8, 9. Okay, tangent of 31. So type in 31 and hit enter. And so the building is 120.17 feet. Tangent, remember, tangent's just a ratio. It's a fraction. If you're given your angle, it's the opposite side divided by the adjacent side. It's always going to be the same for a 31-degree angle. That's why this works. Could I do a tangent by freehand? What do you mean? No. Well, you guys, someone a long time ago, I mean, the tangent of 31 degrees is always going to be the same thing. In fact, if you want to see what it is, everybody hit tangent of 31. And hit enter. The tangent of 31 is 0.600860619. That is, you could get that ratio. I mean, if you turn that to a fraction, let's see if this will turn it into a fraction. It might not. Yeah, it won't do it. It means the opposite side divided by the adjacent side. I'll show you some other problems here that might help answer that question. How about say that again? The calculator just knows that the tangent of 31 is 0.6008, right? It knows that because it's programmed into the calculator. How do you know that? Because that's what I'm trying to say. Because someone took a 31-degree angle and made it into a right triangle, and they took the opposite side and divided it by the adjacent side, and they got the ratio. Just like on this geometry sketchpad. Let me bring it back up. My angle's 23.61 degrees. Okay? The tangent is of that is 0.44. And someone took that by measuring this length over here, opposite side, and dividing it by adjacent side, and they got 0.44. Let's do that. I don't know if I can move it from here or not. You want an angle of how much? 31 degrees? I'm going to have to move this right here. It's called Geometry Sketchpad. I got to go grab this over here. Oh, wait, maybe I can do it from this bottom one. Hey, Drake, go over to my computer. Grab that point right there. See this angle right next to it? Start dragging it down. Oh, whoops, you're not dragging it down. Click out in the open. Oh, wait, where'd my point go? Here, by touching this, I think I kind of messed it up. Let me do it. Okay. Let me grab this point. Okay, here we go. I can grab this one now, you guys. I'll make a 31-degree angle, okay? What was it? 31 exactly? I'll try and get as close to it as I can. That's about as close as I'm going to get, 30.99. Okay? Remember, 0.6008 was, JD, are you watching now? You asked me the question. Look at my angle is 30.99. That's close to 31. Notice my tangent's 0.60. On all three of these, no matter what the sides were, that's what it is. It's always going to be the same. So it doesn't matter what it is. Hey, by the way, you guys are lucky you have calculators. Back when I was in high school, guess what we had to do when we had to find the tangent? When we had to find a tangent of some angle or a sine of some angle, in the back of every textbook was this glossary about this thick that had all the tangents and tenths of tangents. So it would be like for every angle up to 180 degrees. So like if you want to find the tangent of 42.5 degrees, you'd have to go find 42.5 and find the tangent in there. We had these big thick, what do you call it, appendices in the back of the book that you could look in to look it up. So we always had to open our book up and look it up. Now you guys just punch it in the calculator real quick. And it's kind of nice, okay? So that's how we get it. Does that help you understand that, JD? Okay. So let me do another problem, you guys. And so you goes that building is 120.17 feet high. I skipped this one. Maybe that's why you're having a hard time understanding it. Everybody look at this one right here. If this is A, this is B, and this is C, this is going to be little c, this is going to be little b, and this is little a. We always take opposite of angle A is little a, so this side is little a. Opposite of angle B, which is right over here, is little b, and the opposite of angle C is little c, okay? If I asked you to find the tangent of angle B, we don't know what angle B is, the measurement is, but it doesn't really matter. If I'm asking for the tangent of B, I want to know, what's the definition of tangent, you guys? Opposite over adjacent. So which side's opposite? Little b. And which side's adjacent? Little a. So this is b over a. Do we understand that? Because by definition of adjacent, on a right triangle is the angle next to an angle that's not the hypotenuse. This C is the hypotenuse. The side opposite right angle, which is the longest side, is the hypotenuse. Okay? Okay, find the sine of B. What's the sine of B? So what is that? Yeah, opposite over hypotenuse, which is little b over little c. Because the opposite of B, a big B, is little b over c. And the cosine of B, what's that? A over c. Now, I want you guys to find the tangent of angle A. What's the tangent of angle A? Say that again, Talon. Little a over little b, right? Because you guys look, now my reference angle is up here, so which side's opposite of it? A, right? And B is adjacent to it. So my opposite and adjacent switched. You guys get that? The opposite and adjacent switched when I changed reference angles. Okay, go sine of A. What is the sine of A? Say that again? No? Yeah. Opposite of A is A, and then hypotenuse is C. So A over C. Notice that the sine of A and the cosine of B are the same thing. You notice that? Okay. Last one. What is the cosine of A? Cosine of A is adjacent to A, which is B, over the hypotenuse C. And notice that the sine of B and the cosine of A are the same, right? Well, it's just the sine of B and the cosine of A are going to be equal. So sine and cosine will give you the opposite if you go the opposite angles. Now, we never take the sine, cosine, or tangent of the right angle, C. So I would never ask you for the sine of C or something like that, okay? All right, you guys know everything you need to know. Let me hand out the assignment.